Hi, and welcome to this session on the green-golden ratio, or how to design for sustainability and profitability. My name's Dave McDermott. I'm a Director of Solutions Engineering for aPriori in EMEA. I've been working with customers and potential customers on exactly this, the balancing act between sustainability and profitability or product cost. Let's start with the title of this session, the green-golden ratio. There's two elements to that title. The first part is green, that's easy. That's to do with sustainability. Sustainability is a relatively new concept, especially compared to the golden ratio. The golden ratio is billions of years old. It is a number. And this number is found in crystal structures, in the shapes of animals and creatures and life on Earth. The way rabbits breed is based on the golden ratio. So let's explore that first of all. What is the golden ratio? Well, this is the shell of a nautilus, and for those who know, this is somewhat synonymous with the golden ratio. The shape and structure of that shell is based on that golden ratio, that number. And as are many other forms of life. The principle is quite straightforward, that whatever was previously built in the structure will be added upon in the next evolution of the shape of the shell. And how do we calculate the golden ratio? Well, we need to look at what is known as the Fibonacci sequence. This is a sequence of numbers that begins with 0, nothing. And then there is something, 1. From nothing to something. This is why the Fibonacci sequence and the golden ratio is also brought up in the conversations and teachings and scriptures around divinity. From nothing to something. And then what we do is we add those two together to get a new number. And then we take that new number and its previous number, 1 and 1, and add those together to get the next number in the sequence, 2. Then 1 add 2 equals 3, 2 add 3 equals 5, 5 add 3 equals 8, and so on unto infinity. And that is the Fibonacci sequence. The ratio between each of these numbers and its predecessor can be calculated. And the easiest way to show this is with a little demonstration in Excel. So in Excel, we'll copy the Fibonacci sequence. So we have nothing and then we have 1. And the next number is equal to that number plus the previous number before. And expanding that out, we have the Fibonacci sequence that goes on into infinity. The ratio between each of these numbers and its predecessor can be calculated. Equals that divided by that number there. And then if I continue that sequence of finding the ratio, you'll see that we start to trend or tend towards a consistent number. Very quickly it moves towards this number here, 1.618 something something something. And that is the golden ratio. The golden ratio is defined as 1 plus root 5 over 2, which in an approximation is 1.62. The green golden ratio is some other number. Perhaps it is this one that creates a relationship between the balancing act of making sure something we design is affordable and sustainable at the same time. And that's what we'll explore in this session here. We'll start with that balancing act, how we juggle between profitability and sustainability and the challenges of doing that. Then we'll look at some examples of how we actually make an impact on carbon without compromising cost or complexity, how we try and strike that green-golden ratio. And lastly, we'll look at how we identify opportunities with AP analytics to find out where the best ones lie, perhaps even finding our own version of the golden ratio that we can use as an analytical tool. This diagram represents the 3 scopes for carbon reduction for manufacturing companies today. And in there are many opportunities and focal points for those companies, like for example, giving all the workforce bicycles instead of cars can have an impact on the carbon footprint of that company. But the biggest area and the most significant ones for manufacturers of discrete products is around these two big areas here. The carbon footprint of purchased goods, things they procure from the supply chain, and the use of the products. And those two elements form production CO2 and through life CO2. But it's a balancing act. And they can trade off different elements of the design or the manufacturing process or the manufacturing location to impact those things. And that balancing act is dependent on many factors. So for every industry, they have different pressures and constraints, and the way in which the product is used in the world is different too. The material, the location of manufacture, and the manufacturing process also have an impact on production carbon and through life carbon as well. And the physical design as well, the shape, the size, the volume, these are all the major elements. And what comes out of the process is different varieties of manufacturability, complexity, the weight of the products impacted by all these things, as is the energy efficiency. You can design something to be more energy efficient, but, well, how much production carbon is required to go and do that? And each industry, like aerospace, for example, depending on the material they choose and the process they use to make things, and the design of those shapes, the weight can be impacted, which has a significant impact on through life CO2. But as the aerospace world moves into eco-fuels and perhaps even electrification, then they will be feeling the same pressures that other companies do, like the world of electronics and consumer goods, where they may be more focused on the production carbon. This balancing act has to be conducted with thousands of variables, including the design itself. But coupled with that is another layer of complexity in the whole equation, and it's the other part of sustainability, because companies need to be sustainable with their products, but they also need to be sustainable as a business. They cannot afford to make things really expensive to combat carbon footprint. And just the other week I was speaking to an automotive manufacturer who wanted to talk to us about just analysing and understanding and reducing carbon. They didn't want to look at cost, just the carbon element. But the two are coupled together, so much so, my suggestion to them was to build all their cars from carbon fibre and titanium, to lightweight the cars to impact through life CO2. Of course, they couldn't do that because the cost of the cars would be unaffordable. Therefore, the two are coupled together. And if we compromise the cost to try and achieve carbon targets, then we're not going to be around very long as a business, and therefore we're not even existing to be sustainable in the world. So that's the complexity challenge we're up against. So how do we use aPriori to make an impact on product carbon without compromising cost, or at least striking that balance between the two? How do we use the manufacturing insights? Well, I'm going to look at a couple of examples. I'm going to start with one where we're going to design for sustainability, but we're going to design with the real world in mind. And in this example, we are already engaged with the supplier, and we need to stay with that supplier. It's no use finding the optimum manufacturing process if we can't find somebody who actually has that optimum process. In this example, we don't want to change our supplier. They're a key supplier that produce parts regularly, and when the world gets disrupted, they maintain their supply chain because they're a good company. We want to work with them. But they happen to have slightly bigger machines, which is fine by us. We can then start to think about sustainability with respect to that actual company. Now, to go through this example, I'm going to start off in aPro. And I'm doing it in aPro because what we're going to look at here is a combination of design concerns and design ideas, as well as manufacturing and cost engineering type activities. And aPriori Professional is the place to go and look at that in. So as I said on this part, we already have a cost analysis done, but it's based on a slightly bigger machine than is required, and that therefore forms our baseline for anything we want to do around sustainability improvement. The places that I look for sustainability improvement are actually all over aPriori. For example, I can see a material utilization up here of nearly 80%, which isn't very good because we're regrinding and wasting material in the process. I can see the breakdown of different parts of the process. Here we're just doing all injection molding, so that's the biggest contributor. And in my sustainability tab, I can see the contribution from material and from the process. And actually there's a significant element from the process itself. I can also see different materials of different grades that I can choose from that are more sustainable. So these are the obvious things to go and start looking at. From a design guidance perspective, there are manufacturing issues that are driving the cost and therefore the carbon in the wrong direction. For example, we've violated some maximal wall thicknesses here on this component. We're up to nearly 13 millimeters thick when aPriori is suggesting a maximum of 3.5 for this grade of material. And in aPriori we can see where those are. So all the material thicknesses above 4 millimeters, say, aPriori can show me them. And on this part, you see all the red dots represent wasted material and wasted process, but also it represents where perhaps the design needs to be that thick to be structurally sound, but well, let's go and find out, because that's just wasted carbon, wasted money. Also in here are a list of different materials that impact the production cycle time. So for my grade of material, ABS, here are other ABSs that have significantly less cooling time. They are more expensive per cubic centimetre, but perhaps they are more carbon efficient or cheaper to manufacture. And it's not always the obvious choice for design people that cheap material equals cheap production and lower carbon. It's a complex equation. aPriori is also showing me where additional carbon and cost is captured in the design of the tool itself. So based on my design, the tooling is going to require some extra lifters to make my features in my design. So there's a whole bunch going on in there and lots of factors I can impact on the design. So the first thing I'm going to do is redesign the component to account for some of those facts. My new design looks like this here. This is my new design. I have 2 ribs instead of 1 and I don't have those undercuts. I've managed to level out the wall thicknesses and make sure it's still structurally sound. And comparing the old design to the new design, well, on the right hand side is a new design. As you can see, the carbon has come down nearly 15%, so reduced carbon, and the cost has come down nearly 20%, somewhat related. It's not always as simple as that, as I'm about to demonstrate. So also suggested in design feedback was changing the material type. So I'm going to select a glass-filled material as was suggested and just set that cost off and running, get it re-evaluated. The new material contains glass fibre, and according to aPriori this will cool a lot quicker in the tool. It's a more expensive grade, but I now have a balance between the cost of the material and the cost of the manufacturing process, and the carbon of the material and the carbon manufacturing process. It's a complicated equation. I don't need to worry about it. I just let aPriori sort it out. And within a few seconds, aPriori's come up with the new answer. Now, there's lots of ways of exploring the difference from one design to the next, but in aPriori we've introduced a new feature so you can plot various things like fully burdened cost versus total carbon. So as you can see here, the purple bar shows you my cost. My cost has come down, but unfortunately my carbon has crept up a little bit. Not by much, but some. My goal is to reduce both, or at least find a kind of compromise between the two. So far, so good. Another area which we can impact the manufacturing carbon and the costs is through the design of the tooling itself. So either working with a manufacturing engineer or just as a design engineer who has some awareness of manufacturing options, let's say we change to a multi-cavity tool. And this is quite a low volume part, but well, we can at least try it out, see what impact it's going to make. So we're going to go to a 2-cavity tool. Again, the analysis goes off to run, and just for people who have not been using aPriori, while it's doing this analysis, it's doing all the hard maths in the background. I could be getting on with thinking about other more important things, like the next design iteration, or be working on the drawing for this component. So I now have a new data point on my graph. Let me change this to total carbon. And you can see now that my cost has come down, but my carbon has gone up significantly. Now that could be my new manufacturing strategy, and to solve the carbon problem, I might want to start thinking about supply region. So for example, if these are the constraints we're really stuck with from a design and manufacturing perspective, then I could look at lower carbon regions like, say, Sweden, and rerun the analysis in there to see what impact a different zone is going to have. Now, we're not suggesting here that the design teams make decisions about manufacturing location, but we can very quickly, just within a few seconds, understand if we can solve our cost or carbon problem with going to different regions of the world. If that's the only answer, we take that to the procurement teams early in the design process. That's a very powerful insight that can support more strategic decision making. So now when I plot the graph, you can see that my carbon is starting to come back within check again. We're coming back on the carbon front. So I could offset carbon by moving manufacturing to Sweden, but maintaining my lower cost, or somewhere in between. In fact, we've looked at lots of different options, including a hot runner system. So we actually have a variety of different manufacturing design options to look at. And the easiest way to look at this is through AP Analytics. So along the bottom are all the different design and manufacturing options. And now I'm plotting from left to right the carbon drop. So we're focusing on carbon here. So from left to right, we're reducing carbon, and the blue bar represents the cost of each of these. So with respect to my green golden ratio, it's somewhere in here. There's a balance between cost and carbon that I can choose. Low carbon over this side, low cost over here. Where do I pick the right option? We'll come back to that later on. In this example, we're going to embrace some opportunities that come our way, especially in this case where weight is not critical for this component. My component is a flywheel. Here it is in AP design. Now the flywheel's job is to store energy as a rotating mass, so the distribution of weight is not as important as the weight itself. Now we have some physical constraints in our product, but weight is not that critical, shall we say. If I look at the sustainability information inside aPriori, I can see most of the carbon footprint comes from the material itself and a little bit from the manufacturing process. So if I want to impact sustainability of this part, then I've got to focus on material. Going to my material selection window, the chosen material is a cast aluminium. It's our standard approach to things in our company. We've been doing it for years. And aluminium has a carbon footprint of 13.5 kilograms of CO2 equivalent per kilogram of aluminium. So what other materials could I use? Well, if I sort this list here by emission factors, you can see right at the top of the tree are grades of steel. And these grades of steel have a tenth of the carbon factor of that grade of aluminium. And there's lots of other considerations when we're using steel, like for example the casting process is going to be more intensive because it takes a lot more energy, but by how much? Steel is stronger but it's heavier also, so can I redesign it to accommodate heavier weight, distribute the weight properly and make sure it's strong enough still to do so? And this is the design that I've come up with. And remember, I'm now using a sand casting process, so I can be a lot more funky with the design and create more organic shapes that allow me to distribute the steel as widely as possible. And when we're trying to maintain the same rotating mass, it becomes a bit of a design challenge to do that. But it's easy for me to do that in the CAD tool. It's also easy for aPriori to do the analysis of the cost and the carbon in the manufacturing process. And you can see here our carbon's come down quite significantly by using that material. And now the process is more important than the material itself. I need to make sure cost isn't compromised, so let me compare these two side by side. So the first thing we'll see here is that the carbon has come down nearly 73%. That's a huge reduction. Imagine if we could do that everywhere in our products. What about the cost? Well, the cost has crept up 3.3%. I'm quite certain we could live with a 3.3% increase in cost for this part, given the carbon footprint reduction. In fact, for some companies, that small increase in price can be easily justified and accommodated by their customers when they're selling greener products. But how much is a reduction in price that we can accommodate? Where is that green golden ratio? Of course, aPriori is good at telling us where we can look for opportunities to improve carbon or cost on piece parts and assemblies. But in our organisation, our products have many components in them, and we have many products. Therefore, where do we begin to look for these opportunities? Well, we use AP analytics, because inside each manufacturing insight are many more insights we can use to classify and filter and plot reports to point to opportunities. Opportunities for just pure cost and carbon reduction. So this first graph we look at has up the vertical axis cost per kilogram of the part, and on the bottom axis CO2 per kilogram of the part. And the size of each of these bubbles represents manufacturability score. So big bubbles are complex and difficult to make. And we could factor that into evaluation of extra process, extra complexity, which equals cost and carbon. The ones over the right hand side here, like this one, contain more CO2 per kilogram of parts. So these are consumers of CO2. This is where I start my carbon reduction. And the components high up over here are ones that are more expensive per kilogram. These are my focal points for cost reduction. And once I fix one problem over the right hand side, I can start to narrow my search down. And of course, somewhere in here is the balance between cost and carbon on these components. When it comes to carbon reduction, I can plot all the components I'm interested in on a graph like this, where the vertical axis is now the material footprint from carbon, on the bottom axis is the process footprint, CO2 in the process. And each component can then get assigned to a quadrant based on the analysis that's done by aPriori. The ones up the top right hand corner are the biggest contributors to carbon, and I can see whether this is provided through process or material. Once I've addressed these components, reduce the carbon by doing what I've just done a few moments ago, I can then focus on some of the lower hanging fruits and continually chase carbon through the product development process, or as we move towards our 2030 targets. These components over here are all about the process footprint. These components are about material. And I can bring in the right teams, whether they're from the manufacturing world or the design world, to help solve some of these problems. So we can now not only find the opportunities, but then start to classify them so we engage the right people to solve the problem. Now, manufacturability, that aPriori understands, it looks for design for manufacturing issues. These can also be found as well, and they point to wasted energy. There's a relationship between energy and manufacturability, of course. So if we take a process group like, say, machine components, and we plot all the parts on the vertical axis is cost, along the bottom we have weight, then there's a trend of cost per kilogram, as we saw earlier on. And above that trend are the components that are consuming more cost and potentially carbon. But they're also the size of these bubbles, and the color of these bubbles represents cost and manufacturability. So purple bubbles that are big above this line are more difficult to make and highly likely to contain more carbon in the manufacturing process. There's another source for identifying cost and carbon reduction in the process by looking at manufacturability. But the biggest challenge is that when we look at cost and carbon, they are not the same thing. We are trying to compare apples with oranges. So the world has found a way of handling that. We call this internal carbon pricing, or ICP. The idea is that we put a price on the carbon footprint. And that price is a real price for some people. For example, if we're importing materials into the EU from outside, we have to pay a tax. Or if our carbon footprint is too high or we don't achieve our sustainability goals, then we pay higher rates of interest on loans. All of these things ultimately cost money in the business. One of the biggest ones, of course, is if we don't meet our carbon targets, our revenue is going to be impacted, our sales will drop, especially if we are a company that's focused on it. So in aPriori, we can plot this. On this graph here, we've got a component that's manufactured in many parts of the world, from Europe over the left-hand side over to some of the Asian countries here. And if I plot the carbon footprint for each one, then you can see it ranges from a low footprint over in Norway, high over in India. In fact, it's over double in India there. The cost of manufacturing each of these regions is represented by the blue bar. So as the CO2 goes up from left to right, the costs seesaws up and down. Within the digital factories are other pieces of information like the region of the world that we can use to calculate the ICP factor. And the equation of that is different for each company, and we can just modify that within AP Analytics. And now I'm looking at a pure plot of the real ICP cost of these components. And now the red line tells me where I should start thinking about manufacture. Hungary and Slovakia are kind of the obvious targets because they're local to me in Europe, for example, in my case. But here Brazil is a very interesting region. Their costs are relatively low, but their carbon footprint is also, and it makes it a very attractive place for us to go and get things manufactured. And I can start to think about my business strategy with Brazil in mind, especially if I'm manufacturing in different parts of the world. How could I work with major supply through Brazil to keep my carbon footprint low without impacting cost? Because the real reason that companies are in business clearly is to be profitable, is to make money. And the real green companies are the ones that are green and profitable because, as I said earlier on, if they're not profitable, they don't exist. They don't exist to be green. This balancing act between being sustainable as a business and being sustainable as a company with sustainable products, this balance is only becoming more important, certainly in the years to come. And aPriori is going to help us find that green golden ratio.